Hello students, how are you? Hope all of you are healthy and fine. I can understand that you people get too much bored with your online teaching schedule, but it's the phase of our life which we have to come across along with proper management of studies. As well said by great scientist and former president of our country, Mr. Abdul Kalam. All birds find shelter during a rain, but eagle avoids rain by flying above the clouds. Problems are common, but attitude makes the difference. With this beautiful note, let us start next topic of our chapter Indices and Logarithms. Three standard laws of logarithm. In this, the first law is product law. It states that log of mn to the base a is equals to log of m to the base a plus log of n to the base a. I can explain this with the help of example. Suppose you need to calculate log of 2.3 into 3.7 to the base 5. Then instead of doing the lengthy calculation of this, with the help of logarithm, this can be further simplified and can be written as log of 2.3 to the base 5 plus log of 3.7 to the base 5. And if we have multiple numbers in our multiplication, then we can solve this further by changing the multiplication sign into addition. Now let us come to the second law, which is quotient law. It states that log of m upon n to the base a is equals to log of m to the base a minus log of n to the base a. For example, if you need to calculate log of 2 upon 3 to the base 5, then this can be further written as log of 2 to the base 5 minus log of 3 to the base 5. The third law is product law. This law is where we are going to use maximum in our questions. It states that log of m to the power n to the base a can be written as n log of m to the base a. It means here this n is in multiplication. Let me explain this with the help of example so that it becomes crystal clear to you. For example, if I need to calculate log of 2 to the power 3 to the base 7, then this can be written as 3 log of 2 to the base 7. Let us do some deductions from these laws. First deduction is log of a power x to the base a is equals to x. Now let us see how is it possible with the proper explanation. For solving this, let us take the RHS of this. That means this one. Now using the power law which we have studied just now, this LHS can be written as x log of a to the base a. Students, please note that here the power x is written with the log in multiplication. Now we know that log of a to the base is equals to 1, which we have already studied in previous class. So in place of this, I can write 1 and x into 1 is x, which is equals to my RHS. Now the next deduction, a to the power log of x to the base a is equals to x. Now let us see how is it possible. Now changing simple exponential form into logarithmic form, I have changed the LHS of this deduction into this. That means this LHS can be written as log of x to the base a equals to log of x to the base a. Now girls, we have already studied that whenever we have log of x to the base a equals to log of y to the base a, this implies that x is equals to y. Similarly, applying this rule, we get that x is equals to x. It means for both the cases we are getting x. That's why we have proved that this is equals to x. Topic is base changing formula. In this, we have only one formula which says that log of m to the base a is equals to log of m to the base b upon log of a to the base b, where m, a and b, all of these should be greater than 0 and a and b should not be equal to 1. Why we are writing here? Because we know that if this here a become 1, then the value of the denominator will be 0, and when we get the value of denominator as 0, then this fraction will be not defined. Therefore, the special condition given here is a and b should not be equal to 0. Hope this extra information must be clear to you. Now, let us do some deductions based on this. First deduction says that log of m to the base b is equals to log of m to the base a multiplied by log of a to the base b, which we simply calculated from this our formula by only cross multiplying this. That means we have cross multiplied the our given base changing formula, and from that we got this first deduction. Now the second deduction says that log of a to the base b into log of b to the base a is equals to 1. How we got this? Let us see its explanation. From the formula we have this one, that is log of m to the base a is equals to log of m to the base b upon log of a to the base b. Now in this formula, if I substitute the value of m is equals to b, means here if I substitute this equal to b, then what are the changes in the formula? Let us see. Here in LHS, in place of m we can write b. In RHS, here also in place of m this will be replaced by b and denominator as it is. Now in numerator, here this becomes 1 because we know that log of b to the base b, or for any other number with the same number and the log, the value of that is equals to 1. So in place of numerator it becomes 1, and hence when we cross multiply it, we got that log of a to the base b and log of b to the base a is equals to 1, which is our second deduction. Now let us see the third deduction. Third deduction we have simply calculated from the second deduction by only cross multiplying it. Here I kept this log of a to the base b on LHS, and this term log of b to the base a shifted to RHS, and this gives us my third deduction. Let us do some example based on the topic which we have studied now. The first example is evaluate 3 plus log of 10 raised to the power minus 2 to the base 10. Here let us see how we can solve this. In this, first let us keep 3 as it is, and by using the power formula, this whole term changes to minus 2 log of 10 to the base 10. Students, please note that by using the power formula here, this minus 2 shifted here. Now we know that log of any number to the same base, the value of that is equals to 1. So it means the value of this is equals to 1. That means here we have written 1. So we are left with 3 minus 2, which is equals to 1, is the solution of this question. If log of 7 minus log of 2 plus log of 16 minus 2 log of 3 minus log of 7 upon 45 is equals to 1 plus log n. Then we need to find out the value of n here. So let us see how we can calculate the value of n. In this, first we'll keep some terms as it is and we'll make changes in some of the terms, like log 7 as it is, log 2 as it is, log 16 same. Now next term we have is minus 2 log 3. Now here by changing this by using the power law, this can be written as log of 3 square. That means whatever we have done in our example first, we are doing the reverse of that. We are changing this to log 3 into log of 3 square, then minus 7 upon 45 as it is, and we know that log of 10 is equals to 1. Just recall here students that as here the base of any of the log is not given, so according to our rule it means the base of all these log is 10, because we know that if no base is given in any of the log numbers, then that is considered as 10. So that's why in place of this 1 here, I can take it as log of 10, because it means this is log of 10 to the base 10 and this is equals to 1. So that's why here in place of 1 I am writing here log of 10 and after that log of n as it is. Next step is we have that the numbers which are in addition, that changes to multiplication, and the which are in that is subtraction, that goes in denominator. This we have done by using the product and the quotient law. Similarly in right hand side also, as they are in addition, so it changes to multiplication. Now after that, this is the simple calculation, mathematical calculation. That means 7 upon 45 is here, so 45 goes in numerator. After that simple cancellation here and multiplication, we are left with log of 40 and in right hand side log of n. And now on comparing both the sides, we got 40 is equals to 10n, and from here we got the value of n is equals to 4, which is our answer. Now let us do the next example, which is we need to find out the value of x. The question is log of x to the base 2 plus log of x to the base 4 plus log of x to the base 16 is equals to 21 by 4. Now let us see how we can solve this. Students, just now we have done the deduction of base changing formula, which says that log of a to the base b is equals to log 1 upon log of b to the base a. We are using this deduction of the base changing formula in this question. That's why here log of x to the base 2 becomes log of 2 to the base x. This changes to log 1 upon log of 4 to the base x, and the third changes to log of 16 to the base x. Now in this, the right hand side, keep it as it is. Then as it is, here this 4 can be written as 2 square, 16 can be written as 2 power 4, and RHS as it is. Now why we have converted 4 into 2 square and 16 into 2 raised to power 4, so that we can make the base of all the logs as same. Let us see how. In the next step, this is as it is, and for the next 2 square can be written as 2 log of 2 to the base x by using the power law here. Similarly, in the next step also, by using the power law, it changes to 4 log of 2 to the base x, and the right hand side as it is. Now students, if you see that we have made the base of all this as same, so in the next step I can take 1 upon log of 2 to the base x as common, and the left out numbers are 1 from here, 1 by 2 from this one, and 1 by 4 from here, and the RHS as it is. Now after taking the LCM and solving this, we got 7 by 4. 1 upon log of 2 to the base x is equals to 21 by 4. By cross multiplication, this becomes log of 2 to the base x equals to 7 upon 4 into 4 upon 21. So here this get cancelled and this also get cancelled. So we are left with 1 upon 3. After this, the next step, we have simple changes the logarithmic form into exponential form, which becomes x to the power 1 upon 3 equals to 2, and by taking cubic cubes to both the side, it becomes x equals to 2 cube. Hence, the value of x is 8, which is our answer. So students, with this example, this topic is complete. Hope you understand all these topics thoroughly. If you face any doubt, any problem, you are free to write in the comment box and I'll try to get back to you as soon as possible. So we will meet soon with some new topic in our next class. Bye bye and have a good day.